Esquire Higher Applications of Maths 2022 question 1. Jill borrows $56.50 from a bank. Annual effective interest rate is 9%. Jill makes 11 monthly repayments of $186.01 at the end of the month. Complete the loan schedule for Jill's loan to show the loan outstanding at the end of month 2. So first of all, we need to work out the monthly interest. So we'll turn that 9% into 1.09. 100 plus 9 divided by 100. So it's 1.09. And it's the power of a 12 because it's 1 month. So if I do that in a calculator, you'll see that I get 1.09 to the power of 1 over 12. That's 1.0072. So we then need to obviously take away the 1 and times by 100 to change it back to a percent. So I need to take away 1 and times by 100. So there it is there. Take away 1 times 100 and we get 0.720732. 0.72%. Now, when you're doing your table, you can use 0.72%. You would even get away with 0.7% of the full amount. I'm just going to use 0.72 because it's easier to do the sums in a calculator than having to keep this one going the whole time. Just when you check the mark scheme yourself, make sure you look at the different options that are available. So this one will be for 0.72%. Okay, so let's start off. I want the interest content of repayment. So the interest content is, we take the percent and times by the loan outstanding. So it's 56.50 times 0.72%, so divide by 100, and that gives me £40.68. So I'll put that in this box here. Capital content of repayment, well, that is just your repayment minus your interest. So the repayment's 186.01 minus your interest, which gives you 14533. And the loan outstanding is the previous loan outstanding minus the capital content because interest doesn't go towards it. So that's 550467. And then we start again. So it's £5504.67 times 0.72%, £39.63. 18601 is the payment minus the £39.63 to give 14638. And finally, loan £5504.67 minus the £146.38 to get 5358.29. And we're done there. Esquire Higher Applications of Maths 2022 question 2. Company provides a team of roofers to re-roof a house, and we've got this table and we have to complete a PERT chart. So let's jump into the PERT chart. We fill in the middle numbers first and the tasks. So the first task is A, and that lasts for 3. Second task is B for 7. The third task is C for 4. And then it goes D and E for 1 and 2. So D, 1, E, 2. Then it goes F and G for 1 and 4. F, G, 1, 4. And then it goes H for 6. And then we've got I and J. And they take 3 and 2. So there's my completed PERT chart. Going forwards, we do a forward scan. So how do we do a forward scan? We start with 0. 0 plus 3 is 3. 3 plus 7 is 10. 10 plus 4 is 14. So they're both 14. 14 and 1 is 15. 14 and 2 is 16. And now we've got a choice. 15 and 1 is 16. 16 and 4 is 20. We take the longest one because we need to wait. So it's 20 for here. 20 plus 6 is 26, and that's us done our forward scan. So we now do a backward scan. So we've got 26 plus 3 is 29, and 26 plus 2 is 28, but 29 because we're at the end, so it's still both just 29. And then to go backwards, 29 minus 3 is 26. 29 minus 2 is 27. So we pick the one which is the smallest, which is 26. If you've got a choice, pick the smallest one. 26 minus 6 is 20 for both of these. 20 minus 1 is 19, but 20 minus 4 is 16. 16 minus 2 is 14. 19 minus 1 is 18, so I pick 14. 14 minus 4 is 10. 10 minus 7 is 3. A completed PERT chart for 6 whole marks. The roofing company works 9 hours each day on this job. State the minimum number of days to complete the job. Well, how do I know how long it took them? The last number, 29 hours. So it took them 29 hours divided by 9. You can use a calculator to see how many that goes in, but you'll see that it's 3.222. You can't have part of a day. You do day 1, day 2, day 3. We'll complete it on day 4. So 4 days. And we're done there. Construct a Gantt chart without float times for this job. Well, the float time is when, if you look at like a task like D, it starts on day 14. It is expected to last a day, but you can actually take your time and end at the end of day 19 if you want. So it's got float time in it of 4 hours. So what is float time? Well, this one starts on hour 14. It can only take an hour, but you could take longer if you need to because you've got all the way up to hour 19. But for the purposes of a Gantt chart for that float time, you'll just do start at 14 and do a box for 1 hour. Usually do some extra boxes that you don't shade in for float time. So let's start our Gantt chart. I'm just going to go down the way, but you can go up the way if you want. So we've got A, B, C, D, E, F, G, H, I, J. So you need to draw some boxes. So you need to constantly check your table. Starts at 0, takes 3 hours. I've already pre-prepared some of these, so you'll need to get a ruler and draw these, but there's 1, 2, 3 hours for A, starting at 0. B starts at 3 and takes 7 hours. So I start at 1, 2, 3. At the end of day 3, take 1, 2, 3, 4, 5, 6, 7. Just making sure I'm counting properly. Okay, C starts at 10 and takes 4 hours. So after 10, 1, 2, 3, 4. Double check anytime I want. There we go. Yep, 10 and 4. Okay, D starts at 14 and takes 1. So I know that this is 14. I have to take 1. So there we go there. E starts at 14 and takes 2. So starting in the same place for E. I'm drawing it 2 along. So there's E. F starts at 15 and takes 1. So that's 14, so that's 15. I wanted to draw it for 1, so there's 1. G starts at 16 and takes 4. So 16 and 4. H starts at 20 and takes 6. So I should be on 20 already, yeah. 20. And that should be 6. 1, 2, 3, 4, 5, 6. And then we've got I, 26 for 3. So there's I. And we've got J, which is 26 for 2. So the last one starts at 26 as well, but only takes 2. So there is the completed Gantt chart. So for information on dogs and fleas for this SQA Higher Applications to Maths 2022 question 3. After study 1, the following bar chart was created. It shows the number of dogs requiring treatment for a flea infestation against the month of the year. Okay, part A, state the type of data that best describes the number of dogs requiring treatment. Okay, let me look at the data booklet for this. It's numbers, so it's something we're counting, so it's numerical. But since we're counting it, it is discrete. So it's just discrete, numerical. If it was something that you could measure or something like height, it would be continuous. The student vet claims that this graph proves that flea infestations are more common in warmer months across the UK. Why is this claim not valid? So let's look at the actual data booklet for this. So the UK is a nation of dog lovers, with 1 in 4 adults owning a dog. Owning a dog is a big commitment. It's important that dog owners need to have a dog, so register them with a vet. One thing a dog owners need to be aware of is fleas. Fleas are blood-sucking parasites. Fleas are found throughout the year and are believed to be more common in warmer months. They are thought to be more common in rural areas. A dog is said to have a flea infestation when it has more than 20. Study 1. To investigate the seasonal variation of flea infestation in dogs, a student vet on a placement in a veterinary clinic in Edinburgh City Centre gathers data on the number of dogs requiring treatment. From appointment records, the number of treatments for flea infestations in the dogs over a 1 year period were recorded. Seems good enough for a whole year. But where we did it? Only in Edinburgh. So watch out for that. So if we go back to our question, it says the student vet claims that flea infestation are more common in warmer months across the UK. Well, if we look at our graph, definitely more common in warmer months, but this is only a local study, so it doesn't tell us anything about the whole of the UK. So that's all that we can say. One clinic in Edinburgh is not representative of the UK. And there we are. You could also say just that the claim cannot be made from a graph. The data gathered for study 2 is shown in the table. So we've got area, number of dogs inspected, number of dogs with a flea infestation, urban, rural, and then just the totals here and here and here. State a statistical test that would be appropriate to determine whether this data provides evidence of difference in flea infestations between urban and rural areas. There is only one test that is appropriate for categorical data, which is what this is, and it's a z-test. So that's our answer, z-test for 2 proportions. So basically what you would be looking at is the fraction that had infestations. So let's have a look at sample 2. Another study in the sample of dogs was inspected for flea infestations over a 3-month period at an Edinburgh clinic, and a similar sample was inspected at a rural veterinary clinic. So the 2 different places, that's excellent. State 1 part of the design of study 2 that would need to be valid to make sure the tests are valid. Well, make sure it's a random sample of dogs. So samples chosen randomly. To fit in with the student vet's placements, the data from the urban clinic was collected from July to September, and the data from the rural clinic was collected from October to December. How this might affect the conclusions of study 2. The conclusions, of course, will be valid because it's not a comparable time period. That's what we need to write. Conclusions won't be valid as not comparable time periods. And we're done there. Maths 2022 question 4. Zach puts £500 in the bank on the 1st of January 2018, 19 and 20. The effective rates are 3.3, 2.4 and 1% per annual or year. And he makes no withdrawals. Find the balance at the end of 2020. 2 ways to do this. I'm going to do it by a timeline method. So we've got 2018, 500, 2019, 500, 2020, 500, and then we'll go to the end of the year, 2021, but nothing goes in. So our interest rates, we do 100 plus the interest divided by 100 to make it into a decimal multiplier. So that would give me 1.033. Use a calculator if you want. 1.024 and 1.01. So we'll start off with 500 times 1.033 and then add 500. So the first one is £1016.50, and then start again. 1016.50, 1.024 this time, plus the 500 at the end of that. and you get 1540.896 or 1540.90. And then we start again. 1540.90 times 1.01 is 1556.309. So 1556.31 to 2 decimal places. Just not the Markscheme of this, the SQA designed it to be 1556.30 instead of 31, but we did say 31 would be an acceptable answer due to rounding, so I think the rounding's fine. Okay, on the 1st of January 2021, Zach deposits another 500 in his account. He makes no further deposits in his account. Calculate the annual effective interest rate needed for 2021 for the balance to be 2100. So we'll look at the present value here. We'll start with 2100 and we're dividing by how much is in his account. Well, he's got 1556.31 plus the extra 500. You can use a calculator if you want to get 2056.31. So if I divide them together, I'll get the decimal multiplier, which I might need to change to percent. So let me just divide them together first so you can see that. 2100 divided by 2056.31. That gives me that. So you now should be able to see quite clearly that at the end of that sum I have to take away 1 and then times 100 to change it to a percent. So I'll take away the 1 now, press equals, times 100, press equals, and we get 2.12, a bunch of other numbers, percent, and we're done there. SQA High Application Maths 2022 question 5. You must fit the spreadsheet school rule. Question 5. When answering this question, complete part A1, C1 using this file, and then complete parts A2, B, C2 using the answers below. So let's read the question first. A school is planning a new building and it is approaching maximum capacity. The school rule in August 2021 was 650 pupils. Approximately 18% of pupils leave by the end of each school year, and 140 new S1 pupils join the rule in August each year. We have to complete the school rule worksheet to predict the school rule in August 2031. So let's go into the spreadsheet. So you just put your dummy name in here. So Clelland Maths, of course. Secure candidate number 0123456. Set a name, whatever you form. Right, let's go. The number of pupils in August 2021 is 650. And we've got 18% leaving. With 18% are leaving, that means that what's left over is equal to 100 minus 18. Now you can get a calculator and work it out if you want, or just press equals 1 minus this box, and it hopefully will do it for you, 82%. If it doesn't work out for you, just get a calculator and type it in manually, 82%. Okay, S1 intake is 140. We have to work out this one, so we're going to have to go into our table. So we'll have to think about what we're actually trying to work out. If 82% are left at the end of the year, then this box is going to equal, let's just take the forward first, I'll do rounding later, but it's going to equal essentially this box, which is 82%, times 650, but we don't want to type 650, we want to reference the previous because we want to do it every time, plus, and we want to add on 140 each time, so this one. Now, that's a basic version of the formula, but there's certain things we need to be aware of. If things are outside of the table, we usually use dollars because we want that to reference that cell and keep that cell referenced all the time. So that's a good rule of thumb. So what is outside of there? Well, we've got D9. So $D, $9 is what we want to put. So we can put that in. And then we've got D10. So $D, $10. And then C14 is fine because we want that to change each time. If it's inside the table, usually you want that to change each time so you don't dollar it. So we've got that to start with, and that would be fine, but we're not rounded. Have a look at this. It's approximately 18% leave, and the number of pupils has to be a whole number. So we can just round this to 0 decimal places. You could also use the integer function if it's exact, but we're looking at rounding here, so just round. And then press enter. And we get 673, and we can just extend that by dragging and dropping, or double clicking, or copying and pasting. And we get an answer of 761. So we have answered part A. So we'll just type that in here, 761, job done. Part 2, comment on the precision of this prediction. Well, the number of pupils leaving each year is approximate. So the prediction is approximate as the number of pupils that leave at the end of each school year is approximate. And with these questions, usually when you're talking about precisions or predictions, if we go back, we look at the variables that could change. For instance, the leavers could change, but really the S1 intake, is that really 140 each year? The question says it is, but that could change too. So looking at these questions, you're looking at just making a comment on these numbers being accurate or whether they can change or not. Part B, comment on the relationship between time and predicted school roll up to August 2031. So let's have a look. As each year goes on, the number of pupils increase. So that's all we have to write. So the number of pupils gradually increases each year. The school moves forward with plans for a new building. This will increase the capacity to 800 pupils. Extend the table on your worksheet to construct a graph to show what is predicted to happen to the school roll in the long term. You must consider what happens beyond August 2031 and then use your graph to determine whether the new capacity is suitable. So let's go back to our graph. We need to extend our graph so we can just highlight and we can start dragging down and just see what happens. Well, it just looks like it's still increasing, so I'll keep going. See if there's any actual, there's a pattern there. So have a look there. We can start to see that it is given as the same number. Do that a few more times just to check. And generally speaking, with a question like this is what you're looking to happen. So we get that. And then we have to make a graph. So let's highlight all the data and don't give ourselves a headache. Insert, recommended charts. Top one looks good. So I'll just press OK. And I'll move that up so that it's in an appropriate place. And let's just make sure the axes are labelled. So graph of number of, let's just call it school roll against year. That seems good. So a title for a graph, and then axes, so plus axis titles. This one's number of pupils. And this one is year. So we've appropriately labelled on a graph, just in case there's a mark for that. Now in this question there wasn't a mark for that, but there will be a mark for it somewhere probably. So just make sure all graphs are appropriately labelled whenever you do them. Okay, so we've done a graph. Let's go check the question. Extend your table and construct a graph to show what has happened to the school in the long term. Well, we've done that. So there's your 2 marks. We've extended the table with the constructor graph. We've made sure that it does something that levels off and we go far enough. If in doubt, go too far. Don't do too little. Use your graph to determine whether the new capacity is suitable. So the new capacity is 800 pupils. Well, where's my graph there? Now this is an exponential graph. And you can see that it's going up and then levelling off. Or you can see that in the table it's levelling off at 776. Now the capacity is 800, it says. So for part 2, yes, the capacity of 800 is suitable as the number of pupils levels off or never exceeds 776. And that will give you your mark there. And then it says to print the school worksheet in value view and formula view. So value view and formula view on one page. So just to click, this is a value view. So we just go to File, Print, Fit Sheet on one page, and then you'll get it all on one page. So that's value view. But for formula view, you go to Formulas, and you go to click here, Show Formulas, and then it will show all the formulas that you've used. So with SQ you can mark it and make sure you've rounded. File again, Print. Make sure you click to fit on one sheet, which is done, and then you just print it and away you go. Just a little note on this. We may ask you, it's come up before, we'll just get rid of these formulas. This graph is called an exponential graph. So this is called exponential growth. If it goes down the way, it's called exponential decay. The other thing you could call it is a recurrence relationship. This is actually doing a recurrence relationship because it's using the previous value to get the next value over and over again. And that's done for this question. We have application maths 2022 question 6. The average price of petrol increased at the following annual effective rates: 2.1, 0.5 and 2.0 from 2018 to 2021. And we have to work out the average price, the overall percentage increase in the average price of petrol over these 3 years. Now, don't be tempted to just add them up. That is not it. Imagine if I started with £100, I would do 100 times 1.021 times 1.005 times 1.02. I would times them by the decimal multipliers. So I need to times them together to get the overall percentage increase. So in other words, I do 1.021. I got that by doing 100 plus 2.1 divided by 100 times 1.005 times 1.02. Once I've done that, you'll see in a minute, we can do it in bits. 1.021 times 1.005 times 1.02. That gives you 1.046627. So with that answer, I'm going to have to take away the 1 and times 100 to find it back into a percent. So take away 1 times 100, 4.66, and a bunch of other numbers, 4.66%. Average price of petrol in 2021 was 136.4 pence per litre. Calculate the average cost of filling a 45 litre tank with petrol in 2018. So we're going from 21 back to 2018, but we already know that the percentage that increase was 4.66%. So all I need to do is divide by that to go backwards. So 136.4 divided by 1.0466. So getting my calculator back open for that. 466,271. That'll just divide by 1.0466,271. That gives me 130.323. So I then need to times that by 45 because it's 45 litres. So just times straight away by 45. That gives you 5864.55 and a bunch of numbers. But that's going to be pence. Now pence looks a bit nasty to me, so I'm going to divide by 100 to get £58 and 645, so 65 pence. 58.65. Due to rounding, you'll get 58.65 or 64.63, and that'll be completely fine. Application of Maths 2022, question 7. You must refer to information, strength and conditioning given the pre-release material when answering the question. You must also refer to the spreadsheet Q7 jump for this question and we have to complete some stuff. So let's have a look. A strength and conditioning coach wants to increase vertical jump height performance in their trainees. The data in the spreadsheet file shows the back squat, weight, and the vertical jump height. We have to construct a scatter plot of vertical jump on back squat for the data. So for constructing a scatter plot, if you look at that CSV, it's just a list of 2 numbers. You could do scatter plots and things in Excel, but usually this is RStudio. It's much easier because you're given a data booklet. So let's do RStudio for this. So I'm in RStudio and I've already uploaded the file, which you can do yourself, and then we just use the data booklet to help us instead of actually trying to think too much. So let's go to find the data booklet. Helpful R commands. Well, there's the first one. We need to read the data. So if you can't remember it, easiest thing to do, copy and paste. Control C, jump into your thing, Control V, and we've got read.csv, and we just need to change the name. Excel data becomes Q7 jump, and then Control Enter makes that command go, and we can see that it's came in here, so we're good to go. Back to the data, we need to attach. So if you can't remember it, again, we can go back and Control C it, and then just jump and Control V, and there, as quickly as that, without any typing, we've attached the data. So to construct a scatter plot, so we go down to our helpful R commands and look for plot. There's plot right there. So I'll just copy that, I'll not think about it. Control C. Just notice it says it produces a scatter plot of X versus Y with black dots. So we've got plot X, Y. So if we check the question, it says construct a scatter plot of vertical jump height on back squat. So back squat is our X. So just make sure you get them the right way round. Start typing back and hopefully it'll come up. And vertical or jump. You can check the data anytime you want to see what the variable name is. X lab axis, so we want a label for the x-axis, so back squat, I think it's going to be in kilograms, and y-axis label, vertical jump height, I think that'll be in centimeters. Main equals scatter plot of y, which is vertical jump height, on x, which is back squat. And control enter. And there we go, vertical jump height in centimeters, back squat in kilograms. Excellent there. Next part of the question. Make an appropriate comment about the relationship between vertical jump height and back squat. So copy that, put it in here. As back squat increases, vertical jump height increases. Or you could say approximately there is a positive linear relationship between back squat and vertical jump height. Part B1, find the correlation coefficient between back squat weight and vertical jump height. So back to our thing, we need to do a core test. So if you can't remember how to do a core test, you go to your data booklet and look up a core test. Core.test it is XY. So X is our back and Y is our jump. And it gives us an output. Let's just copy that into our answers then. Statistical software output. We'll just do that there. And then our answer, we actually need to be able to interpret this. So the core test is a bit, and at the bottom it says 0.828. So we just copy this one. And we're done there. Part 2, find the equation of the regression line of the vertical jump height on back squat weight. Okay, so we're back in. We want to find the equation of the regression line. So data booklet again. Now, AB line puts the line on, but it doesn't give you the equation. It's LM that gives you the equation. So it's that one we want to copy. Y, remember, was jump. And X was back. Control enter. And we get output. Let me just copy that into our file again. So there's our output, but our answer is not our output. We need to be able to interpret this. So coefficients, and intercept is this and back is that. So if you go back to our graph here, the vertical jump height's on the y-axis and the x-axis is back squat. So we can say that for our answer, vertical jump height, or just jump, equals, now you can either do this number times back plus this number, or I find it much easier to do it in the order that is written in the thing. So it says 7.2366, so I'll just write that, plus 0.3593 times back squat weight. Question C. Use your statistical software to estimate the vertical jump height for a trainee who can back squat 165 kilograms. So we need to do a prediction here. So back in here, we've got predict right here. So we're going to use the prediction command. Again, back up here, change all of these variables. So jump, back, new data equals data.frame x, which is back, equals c. Now what's c? C is the number that we want for us in the question, which was 165, I believe. Yes, it was. So we change the letter c to 165. And control enter again. And we get three answers. Let's just copy these into our software output. So statistical software output is this. So there's a statistical software output. We now need to just answer this. So we pick the one that's fit. So it's 66.52568. So 66.5 centimetres. And we have to comment on the accuracy of this prediction. So there's two ways to do that. I'll give you the easiest option. The expected or fitted value is 66.5 centimetres, but the jump height is likely to be between the lower, which is 56.7 centimetres, and the upper, 76.3 centimetres. The other way you could answer this, and I'll not write this in, is you could use the correlation coefficient. If you look here at 0.828, that means there's a strong positive linear relationship between back squat and jump height. And since our 165 kilograms is within our data set, we could say that since there's a strong positive linear relationship and 165 is within our data set, it's likely to be an accurate prediction. But that's easier, just using the numbers. Based on the correlation, the coach advises the trainees that increasing their back squat weight will increase their vertical jump height. Why does the statistical analysis not support this advice? Well, we're saying that the back squat causes the jump height to be bigger. That's not necessarily true. Just because we are connected, there's a correlation, doesn't mean to say that it causes it. If you do think it does, imagine we'd done a graph here and it was number of Mars bars you eat against vertical jump height, and we got the same graph. Would we think that having eaten more Mars bars would cause us to have a bigger jump? No, we just happen to be connected. So correlation is not causation. So that's all you have to write. Although back squat and jump height are correlated, correlation is not causation. And we're done there. SQA High Application Maths 2022 Question 8. You must refer to deductions from salaries and employee release material. So I'm going to copy that in a minute. But it says Sophie starts a job selling mobile phones. Her company provides the following benefits at the end of each month. So she's got a £1,000 salary, £20 for each mobile sold. And then a pension scheme. She pays 2.5% in and the company pay 6.5%. Sophie expects to sell 150 phones per month. Calculate the income tax she pays each year. So let's work out our salary first per month. 150 phones, so that's 20 times 150. Which is 3,000. So that means she earns 4,000 per month. Times that by 12. That's 48,000. Now, we do not work out our tax on 48,000 though, because it says she gets pension of 2.5% before tax in our pension fund. Don't worry about the company's one. They just put that money in, that's for a later question. It's a 2.5% I need to take off to work out her tax. So 2.5% of 48,000. That's 1,200, so taxable income, 48,000 minus 1,200. 46,800 is what we're going to use. So now we need to find the tax bands. Well, I've already copied these in, but let me just bring it up. So there's your standard tax table. We don't need the national insurance, just the tax. So basically remember how this works is, first of all, 0 for 0%, and then we take away each band and times by the percent. We can just put the answers next to it. So I'm just going to do that with my calculator. So I've got 14667 minus 12,570 press equals times 0.19. So the first number is 39843. So I'll just write 39843. Okay, the next one, 25,296 minus 14,667 times 0.2, because it's 20%, 212580. 2125.80. The next one, we'll just check our income, 46. So yep, we're still going. 43,662 minus 25,296 times 0.21. 385686. 385686. And then the last one, is where we're in her income, so 46,800 minus 43,662 times 0.41, 128658. 1286.58. So her tax equals the total of all the numbers. Make sure you don't make a mistake typing them in. I get 7667.67 pound sign. Now, if it asked us for a net pay at this point, we would work out our income tax. Let's hope we don't need to do that, and take away the pension, income tax, and tax from her normal £48,000. Okay, let's move on to part B. Sophie's pension fund earns an annual effective interest rate of 10%. Calculate the expected value of Sophie's pension fund after the third contribution is made. So let's look at her pension benefits again. She earns £4,000 a month, and she gets 2.5% in, and the company pays 6.5. So 6.5, 7.5, 8.5, 9% of her salary is pension. So we need to work out what our pension contribution is first. So pension per month, which is worked out as 9% of her salary, which is £4,000. That's how much she gets. So 9%, 0.09 times 4,000 is £360. So that's how much she's putting in each month. So it's just a little timeline. We've got month 1, we've got month 2, we've got month 3. She puts 360 in. We've got an interest, then we've got 360 in. We've got an interest, then we've got 360 in. And what is the interest? Well, it's 10% per year, so I need to change that to a monthly interest. So it's 1.1 to the power of 112, because it's only every month. So that's what we're timesing by, 1.1 to the power over 12. And if we're timesing the last one, well, immediately after the third is made, so no, that's when we stop. So continuing this question, we're starting with 360. We're timesing by 1.1 to the power of 12, and then we add 360 at the end of that. So that gives us 72287 to start with. So then we take our 72287 and we times by 1.1 to the 12. And well, that's 1 360, 2 360, so an extra 360 on that as well. And that's the third 360. And you get 1088.63. Sophie has a choice to leave the company pension scheme. State a reason why she would not leave the pension scheme. Well, she might not leave because she wants to save for retirement. It's important to save money for retirement. Or the main one, just due to the actual question, is that the company pay in 6.5%. So if she leaves, she will not benefit from the company paying 6.5% to pension. She's effectively losing that amount of money. So either that, or it is important to save for retirement, to save for future. 2022 question 9. You must have fit a spreadsheet Q9 car payments when answering this question. Okay. Maria is buying a car for £15,000. She's arranged a loan for the full amount from the bank to be paid back with level monthly repayments for 48 months. The annual effective interest rate is 9.5%, with the complete loan repayment schedule to determine the level repayment amount and final repayment amount. Okay, so here is the spreadsheet. We've got some boxes to fill in and then find a final repayment. So first of all, the monthly effective interest. To work out monthly, you start off with equals this cell plus 1 to the power of 112. And then we need to take away 1 at the end again. And you get 0.76%. Monthly repayment amount, well, we don't know it, so let's just make a number up, 300. Final repayment amount we'll come back to, so we now need to fill in our table. Okay, so our repayment, well, that equals our monthly repayment, but we need dollars around that because it's outside the table. So $C, $11. Our interest, well, that equals, we need to round because it's 2 decimal places for money. And it's going to be our monthly effective interest rate times the loan outstanding. Now, we want that for 2 decimal places, but don't forget anything outside the table should have dollars in it. So $C, $9. Make sure you double check. Inside the table, no dollars. Capital content of repayment. Well, that's just equal to your repayment minus your interest. So there we are there. And your loan outstanding, well, that equals the previous loan outstanding minus whatever the capital is that you paid. So we can just do that. We wouldn't need to round this one because these ones used the figures already, but we're rounded, so we're fine. And then we'll just extend our table down, 48 months. There you go, just make sure it stops at 48, if not drag up or down. And you'll notice that the final box is not 0 because we just made up 300. So we do a goal seek. We go what if analysis goal seek. We want to change that to 0 by changing the monthly repayment, that box there. So press equals or enter and you'll notice it does it for you. It looks like it's done it well. However, look at our monthly repayment. It says 37406, but it's not rounded it, it's just displaying that. So we need to change that here. You can either change it to 37405 or 37406, it doesn't matter. Basically, we use the 06 because you can round up 8, so I'm just going to do the same. So there you go, 06. Now it will change everything except will be an extra or a little bit less here. So to adjust for that, click this box, check what that says, minus 0.07, so click minus 0.07. If it's a positive number here, put add instead, press enter, you'll notice that now jumps to 0 and you've got a final repayment amount of 373.99. So you can just put that in this box. And we're done there. Okay, the car dealership has their own finance options. Pay £300 a month for 48 months to return the car. Or additional charges will apply if mileage exceeds 24,000. Option 2, pay £300 a month for 48 months, keep the car with an additional payment of 5,000 in the final month. We'll have to open the car finance and complete the car finance repayment schedule to find the annual effective interest rate for option 2. So there's the car finance one there. So annual effective interest rate is what we're trying to find. We don't know it, so we're just going to guess. So 40. I don't know, pick anything you want. Just don't pick anything too small. Okay, again, monthly effective interest rate, so that equals 1 plus this to the power over 12, because it's a month, take away 1, and we get our monthly. Loan period is 48, monthly is this, additional is this. So our repayment equals $C, $11, which is 300 this time, and that's not a goal seek. Interest content of repayment, same as before, $C, $9, because that's the monthly, times the loan outstanding. And we've not rounded, of course, so we go back in our formula if you forget that and go round 2. And we get this number, 42654. So the capital equals the repayment minus the interest. And the loan outstanding equals the loan outstanding minus the capital. Now notice with me, I've picked quite a high percentage here. Now you get some negatives. Do not worry your heads with this. Just go through it and do the goal seek and you'll be fine. So now I copy, drag and drop down for 48 months, but there's one thing I need to remember, that additional payment. So it's an additional payment of 5,000 in their final month. So I'll just quickly change that to say plus 5,000. You notice my goal seek again, I have to change this. So it's what if goal seek, change F63 to value 0. But this time we're not changing the repayment, we're changing the annual effective interest. After a little while we get 11.05%. Notice that says dash or zero. It depends on how the spreadsheet's set up, but that is definitely zero, so we're good. You might be wondering, well, on the previous spreadsheet, we went back up and we checked this cell and we go, oh, there's all these extra numbers. Do we do this for this? We do not do this for this. This is a percent. If we change that, that means we change her payments, but she's agreed to pay 300 and she's agreed to pay 5,300. That is her payments. So they'll quote to her 11.05%, but they'll do it as 11.0464A, so it all works out on their end. Key point is, money you change where go seek back to do decimal places. Other stuff, generally speaking, you just leave it as it is. So C, state 2 reasons why Maria might decide to purchase a car using the bank loan instead of car dealership finance options. So if we look at the finance options given to us, option 1 is pay 3,000 and return the car, or she might exceed the miles. So she might not want to do that because she has to return the car. Option 2, she has to pay an additional 5,000 in the final month, so it's not the same monthly payment each month, whereas the bank loan is. So that's all you have to write, really. So Maria will own the car outright after 48 months without needing to pay an additional £5,000, would be one good reason. If Maria does not want to keep the car, then it is risky, because if she does more than, she will have to pay a penalty. Let's just look at the interest rates. On the bank loan, it's 9.5%. On the car finance deal for keeping the car, it's 11.05%. So the bank loan's actually a lower interest rate. So you could say that as well. Bank loan has a lower interest rate. And there you go, we're done there. It now says value view and formula view, and then print your worksheet. So let's have a look at the worksheets. You've got bank loan, so you just got to file, print it in value view and formula view. To get it into formula view, you just go to formulas and show formulas, and you do the same for car finance. You print this as normal, and then formulas, show formulas, and print your formulas, and we're done there. Okay, SQA Higher Application Maths 2022, question 10. You must refer to information mountain gorillas given in the pre-release material, so we'll look at that in a minute. The 2020 study found that the population of mountain gorillas has increased to 1,004. And an expert has stated that if the mountain gorilla population in Virginia mountains continues to grow exponentially, there will be 1,600 by the year 2032. Determine if he's correct. So we're going to have to look at this pre-release material to see if there's any information to help us with this. It says deforestation happened on a massive scale, blah, 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 blah. A study in 2008, starting on this paragraph, said there was only 680 mountain gorillas in Virginia mountains. A study in 2020 showed that due to conservation efforts clamping down, that had increased, and we know what that's increased to. And we'll come back to this a little bit later for the rest of the question, but we do know that in 2008 there were 680. 2008 there were 680. We know in 2020 there are 1,004. Now, the way exponential growth works is, if over a certain time period, like 10 years, something had doubled, it will keep doubling every 10 years. So this is 12 years, and we now want to know 2032. So let's just check that time period is the same, 12 years, 12 years. So if I know what that's times by, for the next one it'll just times by the same amount. So how do I know the multiplier? I just do 1,004 divided by 680. That's 1.476. I'll take a note of it as a truncated amount, but I'll just leave it in my calculator. So that means to get to the next one, I'm going to times by 1.476 as well. So I'm just going to times 1,004 by that, so I'm just going to press times 1,004. That gives me 1482.376. So that's about That's about 1482. Just rounding down because it's a whole number of gorillas. So that means that the expert is wrong, because 1482 is much less than 1600, and for exponential growth to occur, 1482 must be the number. Adult mountain gorilla eats 30 kilograms of food per day. Estimate the amount of termites and ants in kilograms that a typical mountain gorilla will eat during their adult lifetime. State any assumptions you make. So this is called a Fermi estimate. So we're looking from the second paragraphs. Mountain gorillas are considered adults when they're 10 years old and live an average of 35 years. So there's a trick. It's not 35 the times by, it's 25, because they're adults when they hit 10. And the second trick, mountain gorillas survive mainly on a vegetarian diet consisting of bamboo shoots, fruits and berries. Given the opportunity, they will also eat ants and termites, but the diet will remain mostly vegetarian. So what does that mean? Well, if you're mainly or mostly something, it means you eat more or do it 50% of the time or less, more. So if you're going to pick the amount of termites or ants that the gorillas eat, you have to pick a number less than 50%. So we're going to assume they live adult life is 25 years. We're going to assume the usual, that was 365 days per year to get rid of the leap years. We've got that, we've got to estimate the maximum amount of termites. So the maximum will have to be less than 50%. So what's the closest to 50%? We could be 49.99% or 49%. I'm going to assume 49% of termites per year. Now it has to be 49% because it's the maximum we're looking for, so it's not just any old. So then we're just going to do 49% of 30 times 365 times 25. So 0.49 is 49% times 30 times 365 times 25. 134,137.5. That's about then 134,000 kilograms, thereabouts. The data, if you look at it, is given to two significant figures, 1600, 1004. So 134,000 is reasonable, but you'll get an answer for anywhere between 130 and 140,000 as long as you've rounded it somewhere reasonable. But the key point of this question is 49%.